Before beginning the biomechanical analysis of bowling approach, we should first mention a few biomechanical terms that naturally occur when bowling. First, we need to take a look at friction. The bowling lanes are routinely maintained by applying a thin coat of wax to the wood flooring. This helps reduce friction between the ball and the lane. In addition, the shoes bowlers wear have a thin layer of felt beneath the toes to also reduce friction for the players as they approach the lane. Next, we want to look at velocity and force. By creating more force for the ball, this will result in a higher velocity as the ball travels down the lane, allowing the shattering effect seen by the pins. Lastly, the ball is going to exert inertia after leaving the bowler's hand. Inertia is an object's desire to continue doing whatever it is doing until acted upon by an external force. In this case, it is the pins. This is known as Newton's first law of motion. Now that we have a basic understanding of natural physics that occur during bowling, we can now break down the movements of both the beginner and professional bowler. To start off, we're going to analyze the beginner bowler, which can be seen up top. Okay, so we can see he starts off in a neutral position, and at this moment you can see that he begins to shift his weight downward. Pro bowlers are experts at manipulating their center of gravity by lowering their center of mass. This can be seen by this beginner bowler. Secondly, pro bowlers use their offhand to help keep their balance. This bowler fails to do so, which results in his off-balance finish, which can be seen right there. You can see he kind of stumbles over his feet if we watch it again. Right here you can see an off-balance finish. This is because he didn't use his offhand to keep his balance. Next, pro bowlers keep the ball far away from their body during their backward swing to help lessen the force needed to produce a higher torque on the ball when released. This bowler does this well, so we'll watch this again. You can see here, as he starts, he brings the ball, he fully extends his arm and keeps it far away from his body. This allows the ball to naturally fall in a downward motion so he can produce a higher torque on the ball when released. Lastly, during the downward phase of the backswing, the ball naturally wants to fall, which allows the bowler to focus more on aim rather than energy put into the moving ball. This is an example of gravitational potential energy. And that is the full analysis of the beginner bowler. Now we want to look at the professional bowlers. Okay. The first pro bowler shows a great example of how he pushes the ball up and away from his body, then uses gravity to create a muscle-free swing. So you can see this bottom video, the ball gets extremely high, a lot higher than the beginning bowler. This allows the ball to swing very quickly in the downward motion without him having to use a whole lot of force. Next, to transfer the ball more efficiently, the bowler's knee will continue to move forward once the front foot slides. So you can see, if we go back a few frames, if you watch his front foot after the ball is released, his foot actually crosses the line. So his actual front foot actually slid forward after he released the ball. This helps put more energy into the ball. This next bowler shows how to keep their balance during the backswing, phased by moving his offhand out in front of his body to counterbalance the weight of the ball and to reposition his center of gravity. This is what the beginner bowler failed at. You can see right here that his hand is now out in front of his body and continues to do so as the ball returns back to the frontward position. This allowed this bowler to plant his front foot and keep his balance without falling over. Lastly, this pro bowler shows the importance of keeping the ball directly in line with his head throughout the swing and release, which improves accuracy and the ability to repeat shots. So if we draw an imaginary line, you can see for the most part the ball follows this path from start to finish. In addition, to generate a higher revolution rate of the ball's spin, this bowler keeps his hand on the inside of the ball until just before his release. So if we back up a few frames, you can see that the ball remains slightly on the inside until just before he releases. He snaps his wrist in a slight rotation. This creates a quick spin on the ball, which in turn allows the ball to curve down the lane. So overall, this concludes the biomechanical analysis of bowling. Thanks for watching.